I will be doing question number 22 on page 256. Now the question calls for a diagram that is shown actually below in the textbook. So you have a pole, a horizontal beam, a cable, and a floodlight. The angle between the floodlight and the cable is 30 degrees. The floodlight is 20 kilograms. And the first thing we want to do is label all of the forces. And so, because the problem specifically states that the horizontal beam has negligible mass, it doesn't have weight, which means it doesn't have a force. The floodlight, however, has mass gravity, which would be the weight. There is tension in the cable, and there is a force going this way from the hinge with an unknown angle, and we'll just call that J. Let's define our axes as right is positive and up is positive. And the first thing we want to do is sum up the forces in the x and y direction. So the forces in the x direction would be defined as this line, this force, and this force. Now, from the properties of geometry, we can tell that this is 30 degrees. And because the angle is adjacent to this, the horizontal force, we would use cosine. And notice how it's to the right, which makes it positive. So J cosine theta. And this one's going left, which is negative, so minus T cosine theta, because it's also, the angle is also adjacent to the force. And that is equal to 0 because this is in static equilibrium. Now we want to sum up the forces in the y direction, which would be this one and this one. And so this would be J sine theta, which is in a positive direction because positive is defined as up, plus, because this is also going up as well, T sine 30 minus the mass gravity we have here, which is 20 times 9.8 equals 0. The last thing we want to do is sum up the forces of the torque, and we will define this point right here as the point we want to rotate around. And so there would be two objects that have torque, which would be the tension cable and the floodlight. So, because this one is going in this direction, compared to this, it would be considered going counterclockwise. This is going counterclockwise, which makes it positive. And torque is defined as R sine theta times the force. And because there is no defined R, we would just consider this variable R. So R sine 30 tension. And this one is going in the opposite direction. This one's going clockwise, which means it's negative minus R because it's the same distance. The sign will eventually give you 1, so we don't need to worry about that. Force is 20 times 9.8. And we could solve for this in order to get tension, in which the R's will actually cancel out. And they'll cancel out, leaving you with T equals 20 times 9.8 divided by sine 30, which will give you 392 newtons. So that gives you the tension. And then you take the tension, plug it back into these two equations in order to get the J cosine theta and J sine theta, which are the vertical and horizontal forces exerted on the beam by the pole. So after you plug that in, J cosine theta is equal to T cosine 30, which would give you 339.482 newtons as the horizontal force. And then J sine 30 is equal to 196 minus T sine 30, which is also 196, and that would give you 0 newtons in as the vertical force.